Hello everyone. So today we are going to discuss problem 3147 of Leetcode. And before starting the problem, I want to tell you that for a medium problem, it's not a medium problem, it's very easy problem. Okay, so let's just read the question. Wait. Okay. So in a mystic dungeon and magicians are standing in a line. Each magician has an attribute that gives you energy. Some magicians can give you negative energy, which means taking energy from you. Okay. You have been cursed in such a way that after absorbing energy from a magician eye, you will be instantly transported to magician eye plus K. Means that you have to, if you take energy from a magician ayat magician, then you have to jump K indexes. That's what the question is asking. This process will be repeated until you reach the magician where I plus k does not exist. It means that you jump k times, okay? K times k times k, like I plus k, then I plus 2k plus 3k up till uh you don't cross the boundary. So, okay. In other words, you will choose a starting point and then teleport with k jumps until you reach the end of the magician sequence, absorbing all the energy during the journey. You are given an array energy and an integer k. Return the maximum possible energy you can gain. So that when you are reach a magician, okay. Note that when you reach a magician, okay, just ignore this. You must take energy from them, whether it is negative or positive energy. Okay. So if you are at a position I, you cannot deny that I don't want to take this because it's negative. Okay. So you have to return the maximum possible energy you can gain. So let's see this test case. Let's say, yeah, one more thing. We have to choose a starting point. Okay. So when you choose a starting point, let's say I, then you are bounded to do jumps from that point only, and you cannot go to I plus one and then jump k times from that index because you are getting maximum from I plus one. You cannot do. If you are starting at position I, then you will go to I plus k, I plus 2k, I plus 3k, and so on. So we have to choose such starting point in order to maximize our energy. Okay. So let's say that I start with energy is equal to 5. Then I will go 5 plus, this is the zeroth index. So you go to this index 0 plus 3, 0, 1, 2, 3, this one, 5 minus 5, 0. And then there's no index after this. Okay. So if you start from this, then your maximum energy will be 0. If you start from this, then your maximum energy will be 2 plus 1, 3. If you start from here, then minus 10, from here, minus 5, from here, 1. So 3 is the maximum answer we got, and 3 is our output. Okay. And what is constraints energy total? Okay, 10 to the power 5. And energy nk is from 1 to energy dot length minus 1. Okay. Okay. So I think you understand this constraint, that why it is 1, why it's not 0, because if it's 0, then you will be at that point for the infinite time. And if it's uh, energy dot length, then in the first jump only you will reach the boundary. I mean, yeah, okay, that's why. So, how can we approach this problem? This is a very, I will say, basic dynamic programming problem. And how can we do it? Let's go to the board. Let me share my whiteboard. Wait a bit. I hope my board is visible now. So, whenever I do a dynamic programming problem, I have said you like only one time, sorry, that I love to define the DB state. Okay. What does dp of ij mean, or dp of ijk mean, or dp of I mean? Okay, so defining the dp state, then finding transition state. Okay, this is dp state, this is your transition state, then your base case. Okay, what is your base case, and then final sub problem. Okay, so in this case, let me define this dp state, and trust me, when the moment I define this dp state, you will know the answer. I don't need to do this. You will do it by your own if you have done dp. Okay, so my dp of I represents maximum energy you can achieve when starting position is I and you go up till n. Okay, or you can say, what is the maximum energy you can achieve from I to n? Okay, now tell me one thing. Let's say you are at position I minus k. Let's say this is your index, current index. So what will be the maximum energy you can achieve? I will say it's energy of I minus k plus dp of I. How? See, when you're at this position, you will have to take that energy, okay? And then you will do a jump of k. So I minus k plus k is I. And how do you know the answer for I? Because in dp of I, you have already stored the maximum energy. So you know energy, then dp of I minus k. This way you will be able to calculate dp of I minus k, okay? So if I simplify this, what is dp of I? It's nothing but energy at I that you have to take. You are bounded to take it, plus dp of I plus k. Okay, got it? I think this is very simple. This no problem. And what is the base case? Base case is simple. Can you every time go to dp of I plus k? No, because if I plus k is greater or equal to n, then you cannot reach that index. So what I'm saying is, from I is equal to n minus 1 to j, some j, such that j plus k is greater and equal to n. Okay, which means that these are that indexes from where you cannot take even a single jump. So for that, dp of I will be nothing but energy of I. Simple as that. Because you don't have to take another jump. Okay, so this is your base case. And what is the final sub problem? Final sub problem is nothing but maximum of dp of 0, comma dp of 1 up till dp of n minus 1. Okay, so this is the maximum uh, energy we can achieve, because we know that dp of 0 means what is the maximum energy when you start at position 0. dp of 1 mean what is the maximum energy you can achieve when you start at index 1. Okay, so to achieve the maximum energy, you calculate it by taking the maximum of dp's. Okay, so that was the solution, and let's go to the code part. Let me expand this. So I initialize this DP array. Okay, this is our size of array. While I plus k is greater or equal to n. So let me write it. This is nothing but base case. Okay, this is for transition state. Actually, yeah, it's transition state, but this is our final sub problem. Okay, maximum of all the DPs, and then you return the answer. So I don't think that there should be any issues. I can still tell you, explain you this. So we go from initially I initialize I is equal to n minus 1, then I create my base case, dp of I is equal to energy I. Up till this case is fulfilled, and when I plus k is equal to n minus 1, it means that from I you can jump to n minus 1. So that's not our base case. Then after that we start calculating out ap of j. Okay, this is that I where I plus k was n minus 1, and it goes up till 0. dp of I or dp of j is equal to energy of j plus dp of j plus k. And then you find your final sub problem maximum of all the DPs and you return the answer. So that was all from my side in this video. If you have any doubts, you can put the comments. Thank you.